With the parallel correction finished, it's time to set the absolute 0 points. Each master mandrel, as supplied, has two laser-marked dimensions at the base of the master mandrel. These dimensions will be entered and used at all times to set this presetter and its absolute 0 points. Let's place the master mandrel back in the spindle. Then, using the Setup button, go down to Corrections, select Absolute 0. On the screen, you can select Inch or Metric for the dimensions your master mandrel is in. To make changes, right-click within the box, and a keyboard will come up. You can manually type it in using the keyboard on the screen, or you may plug in a keyboard of your choice into the back of the control screen. Type in both your X and your Z dimensions off of the dimensional values of your master mandrel. When that's done, let's select Record. After selecting Record, the machine is going to ask you to select 2 points, one in the X, one in the Z. Let's move the arm, get the side of the master mandrel to display within the screen. Then, using the Fine Adjust wheel, we're going to get the small triangle on the bottom scale to line up within the green box. Go ahead and line that guy up. Once you get it there, let's select the OK button. Now that we've selected point 1, it's time to select point 2. Let's loosen the arm, move it up to the top of the master mandrel, bring the top edge into display. Then we're going to lock the arm back down. Now, looking at the screen, we're going to make sure we have a nice sharp edge across the top. Using the Fine Adjust, we're going to slowly start to lower and bring the master mandrel towards the center. Okay, as we get lower, you're going to see the little triangle on the left-hand side start to display. We're going to keep lowering or raising, depending on where you're at, to get that triangle into the middle green box on the left-hand side of the scale. Again, that represents about a 2 micron tolerance. Once we get it there, we're going to select OK, and believe it or not, that is all there is to the absolute zeros. This presetter allows you to add offsets or reductions to the spindles. This allows you to convert from a 50 taper to a 40 taper or any other size taper that will fit within that spindle. To add a reduction or an offset, let's start by removing the master mandrel or any tooling that you happen to have in the presetter. Locate your reduction. In this case, the one we have has its own needle bearing basket. We'll remove the one that's in the machine. Going to slide the adapter into the presetter, make sure it's seated correctly. Now going back to the control screen, we're going to go to Systems, Manage Tool References, and we're going to select New. This allows me to input a tool reference number. In this case, it's a 40 taper reduction. We'll type in 40, and we're going to give it a name. You could name it your machine type. In this case, to stay general, we're going to name it 40 taper. Type these values in. When you have them all typed in, select Enter. You can select if your offset is in millimeters or in inches. In this case, we're just changing the Z offset, so we're going to click down in that box, bring up the keyboard, and we're going to type in the offset value etched on the top of the adapter. Select OK, and this adapter has been added. This adapter is now active and displayed. Once the adapter is displayed, you can select the number you gave it, and all tool references that you saved and entered will be displayed. This allows you to select and change easily from one to the other. We are now ready to start using this machine to take measurements. Two of the most basic measurements used are fixed and maximum. This allows you to find the maximum diameter and maximum tool height being used on your machine. Let's start by placing a tool holder into your machine, then locating that tool within the display screen of the presetter. Once the tool is on the screen and in focus, we're going to select the fixed axis icon at the top of the screen. And as soon as we do that, you can see the green light comes on in the upper left hand corner, and our little black triangles reappear in the scales in the left hand and bottom side of the screen. We're now going to use the fine adjust wheels, and we're going to do the same process we did for the absolute zeros. We're going to move each triangle to the center green box within its scale. Again, using the fine adjust wheels, we're going to move both triangles simultaneously into their green boxes. When this is all finished, this tool will be measured for that size. The most common method for measuring is the maximum measuring function on the presetter. This allows you to find the maximum X and Z diameters simply by placing the tool in, bringing it into focus, let the machine catch up for a moment, and it will find it right there for you. Let's take a look at how this is done. Now let's use the maximum function. Take your mouse, select the maximum icon off the icon bar. When you do this, the axes will become flying axes. They will jump or snap to the maximum diameter displayed on the screen. You can now rotate your tool through one full rotation, and the computer will pick up the maximum diameter and the maximum height that is displayed on the screen during that rotation. This will allow you to determine your effective cutting diameter and your overall Z height. Using the preset function. Using our mouse, let's select the preset icon off the display screen. And very similar to the maximum function, the axes will jump to the maximum height and diameter displayed on the screen. But unlike the maximum function, they will not stay at that point. They will follow whatever cutting edge or tool profile is in focus on the screen at that time. This function is very useful for presetting and measuring indexable tools. Using the range function of the presetter. Now, using the mouse once again, let's select the range icon off the icon bar. When I do this, a small plus will be displayed at the tip of my mouse pointer. This allows me to drag and create a box, a display box, on the screen. From this point on, only the geometry displayed within that box will be measured. I can use the preset function, or I can use the maximum function to determine what's within that box. This is very useful when you're measuring form tools or any cutting tool that has a lot of geometry and you want to measure just a small portion of it. Let's cover some additional screen information available to you. Once you've selected your measuring method from the icon bar, a new icon will appear just below that. This icon represents the current measuring method being used. When selected, it allows you to see all the options available for the geometry being displayed in the screen. From these options, you can select any of the methods displayed. As soon as you select them, the screen will change and display exactly what you asked it to display. You may also take your mouse, right-click within either the X or the Z measurement screens, and a new menu will appear. This menu, absolute, difference, incremental, diameter, hold, and then millimeter or inch depending on your measuring system that you're currently in. Absolute measures the absolute height and diameter displayed on the screen. Difference will give you the difference between 2 points. Incremental allows you to set that dimension to 0 and measure from that point. And of course, diameter and hold are fairly self-evident. The TCAM2 is also available with a backlight tool inspection function. With your mouse on the display, right-click, select black-white, the backlight turns on. You are now able to view your cutting edge to look for chip edge wear, any grinding issues, or any other inspection you wish to perform on that tool. You have several measurement functions available to you, either from this screen or the main screen. You can select the Measure Programs menu from the top bar, and you can measure a variety of different items from lines, angles, and radiuses. In this case, we select line. We selected 2 points. The information about that line appears on the right-hand side of the screen. To create a new measurement, right-click again, and it gives you the option to select a new measurement. You can do all of your inspections from this one screen. The Measure Radius function is a very useful tool for geometry that is too large to be displayed on the screen. Select Measure Programs, select Radius. A small plus symbol appears on the tip of your pointer. Pick the edge of your cutting edge you're going to follow and start adding points, anywhere from 2 to 10 points. The display of the radius will appear on the right-hand side, as well as the tolerance for the positions you have picked. To turn off the backlight display, simply right-click once again, select black-white, and you're back to the main measuring screen. Another very useful feature of this presetter is the measure angle. In this case, we have a very strange angled tool we stuck in there. We're going to use Measure Angle off our Measure Programs line. We're going to select 2 points along the first cutting edge. We are going to right-click, select Next Cutting Edge, and select the 2 points along the next edge. Once we've done this, all of our angle information is provided on the right-hand side of the screen. The angle of each line and the inclusive angle between the 2 lines. To get back out of that system, simply select Maximum, Preset, or Fixed off the icon bar. The TCAM2 presetter allows you to create tool lists and save them on the machine. To do this, Let's first put a tool within the display. Let's get our maximum measurements off of that tool. Once that is done, go to System, Manage Tools, and select New. From here we can enter in a tool ID number. In this case we're just going to pick a generic number. Select Enter for that. And we can also give that tool a name. That name can be anything from the machine that it's stored on to the part being manufactured. Whatever you need for a reference. In this case we just picked to type in machine as a generic name. We can now enter in information about that, what its nominal X and Z dimensions are, or if the tool is in the display, we can push the playback button, and the values currently displayed will be recorded for this tool. Now, when we select OK, you'll see the difference symbol shows up, and all we see are the differences from this tool to the measurements saved in the system. And if we go back to the same units, you can see it's actually a 0 for both of these. Once the tool has been stored or selected, you'll notice the name shows up on the right hand side of the screen. Until you deselect that item, it will remain there and the difference values will show up. So to deselect it, let's go up and we'll select System and simply select Deselect Tool. It now drops back to the standard icon and the standard measurement systems that had been selected.